Hello and welcome to another free code session. My name is Jason Bach and I'm going to continue on with this whole dividing of a range because I'm on kind of a roll here. And what do we want to call this? Int number of ranges, which will probably be a uint, but that's okay. So first we're going to do var range sizes is going to be a new int. Oh yeah. So and this is the number of ranges. So okay. Oh, yeah, I can be a little smarter than that. I can say var highest length, which is going to be the max and value minus range start value plus 1 divided by number of ranges. Okay, and that should be an int, which it is. Okay, so we want to do this 4 times. Okay, be nice if there was a repeat, but highest length. We're going to do that. Yeah, you suck. I wish there was a really simple way to say like repeat. I don't think there is. Like I wish there was a way to say I want to initialize an array with this value. Convert all? Converts an array of 1. No, that's not it. Fill assigns a given value of type T to each element. Oh, there you go. So we can say var, what are we calling this? Sizes. Bucket sizes is equal to a new int of number of ranges. Okay, so that's that. And then we can say here fill bucket sizes with highest length. Perfect. And you don't like that. Oh, because it's not returning a value. Yeah, okay, so we fill it. Okay, good. Now I got that. Then find the surplus that couldn't fit evenly into each bucket. So we're going to do var surplus is equal to this, except it's going to be modded. Okay. Distribute the surplus as evenly as possible between each bucket. Start at index 0, add 1 to the bucket while subtracting 1 from surplus. If index wraps to the end of the bucket size array, start from index 0 again, and continue until surplus is 0. Okay. While surplus is greater than 0, we need to have a value out here. Var surplus index is equal to 0. Okay. So while the surplus is greater than 0, we're eventually going to have to do a minus minus on it. Okay. Now what we need to say is in the bucket sizes of surplus index plus plus. Okay. We want to increase that value. And now we need to say surplus index is equal to plus plus mod the number of ranges. Because what that's doing now is it's saying 0, 1, 2, 3. 3 plus 1 is 4. Mod 4 is going to be 0. And so we go back to the beginning and we keep distributing across all the bucket sizes until we get what we want. Okay, so now at this point what we can say is let's actually now create the list of ranges. Okay. I see what it's doing. Okay. Var ranges is equal to new list of range. Okay, for var I is equal to 0, I is equal to 0, k is equal to what is the min? That is range dot start dot value. Is this gonna let me do this? I don't know if this is going to be legal C plus or C sharp. I is equal to less than number of ranges I plus plus. Yeah, you don't like that, do you? Yeah, you can't. That's fine. We can pull this out. There. Var k. Because k, you know, k is a great value. Why would you not have that? We're going to do ranges dot add new range, where your lowest value, your start value, is what k is, and your highest value is k plus the bucket sizes of I minus 1. And it's just that simple. Okay. And then k is plus equal to the bucket sizes of I, because you need to move to the next one. Return ranges, and you're done. All right, so credit where credit is due. That's where that came from. So what I'm curious about now is, before we go off and doing stuff in parallel, let's actually do var ranges based on divide range of range environment processor count. Okay? For each var r, because I can't do that in ranges, console out, right? R. Okay. And let's actually not even do this yet. Okay. Let's push this down to here. Okay. So now let's run it and see what happens. That is beautiful. That is beautiful. Look, would you look at that? Would you just look at that? 25, 37, 50. Oh, I love algorithms. That's so beautiful. I could have figured that out myself. But that's a little bit of work, but it makes sense. I mean, if I now said, instead of 8, and I said 7 here, which is kind of an odd number, what happens? Distribute to the best as it can. Oh, that is so beautiful. I'm adding this to Spackle. Yes, because I have to update Spackle at some point, because I need to. It has a range type in it right now, and so I've always been like, add the divide range or partition range. Maybe that's I'm not sure. Partition range to Spackle. I like that. I'm going to push that down here, and then I'll just add that into there. Okay, cool. I like this. Okay, so I think that's working the way we expect it to. All right. So now, except when I do parallel here, what I want to say is var ranges is equal to divide range, the range environment processor count. Okay. And now what I'm going to say is pass in I for the ranges. Okay. And so now what we should see is something. Should see the same answer for both, but hopefully the second one is an eighth of the time. Because it just dies. That's beautiful. On null exception, one or more errors occurred. Index was out of the range. Oh, ain't that cute. Okay, what did I do wrong here? It gives you a list back. Let's go back to debugger for a second. And let's see what I could have possibly done wrong. I should have commented out doing the calculation first, but that's okay. Okay, so ranges gave me a count of 8. And that's 8. Oh, for God's sakes, don't tell me that this is... No, it should... Like, ranges... Yeah. Okay, now it did everything. Well, that was the wrong one. Why did that break? That doesn't make any sense. I mean, running it in the debugger worked. I gotta stop doing that one for a second, because it's costing me too much time to wait. Yeah, that's... I know it has to do something with the fact that I'm passing in a value. You know what? Var r is equal to ranges dot I. Let's capture this and then throw it into here. And not wait this time. Okay. All right, so now we did that right. So, okay. Let's, okay. One more time with feeling. And so we see that when this runs, I think it was going to be like 9 seconds, it went down to 4. That's interesting. It only cuts it in half. Oh, no. Cut it down into... So it was like 9.3. It cut it down by a third. Okay. So, which makes sense. I mean, I'm distributing the work that's basically CPU bound across all my processors that I have. And it's taking much less time. My fan kicked in. I don't know how that recorded. That might have gotten kind of screwed up for 2 seconds there. But it gives the same value for both. And so this is the point, is you've got all the processors. So I could come into here now and just, bump this up to 5 million to 10 million, but it would partitioning across all the threads. And you could say, well, wait a minute, why don't you, like, what I could do in the real, as I start to think about this more, what I could do is say, well, rather than split it across the range across 8 partitions or 8 divisions, which is my processor count, actually do it across like 32, because it generally, I think, shows with the collapse sequence that the bigger your numbers get, generally the longer the sequences get. So one thread is going to, in this case, take up the most amount of time. One task. That one is probably the 2.81. Whereas if I was even smarter, what I could probably do is divide it into 32 and reduce that whole time, to just a fourth of what that was. This is one of those things that'd be fun to kind of play with and see where this goes. But the point of this is to take this and now put this into a sequence generator that uses tasks in Blazor, and what happens. So I've got some time. Let's just try, first of all, added parallel collapse computation, because computation sounds like an important word. Okay. So let's come back over here, and yeah, I can't have to have all this now in. It is what it is. So it's going to look a little ugly, but that's okay. We're going to have in our web components, we're going to take sequence, and what did I say I was going to call it? Sequence tasks. Okay. And it's going to take task. We're not going to give it a number to start. Okay. We don't need to inject the runtime. We don't need geolocation. Okay. We are going to create the sequence. We are not going to do that. Okay. We will set the results equal to results. Wow, that sucked. That is horrible. Are you kidding me? That's how bad rename is? But if I rename, wow, holy crap. What if I do it here? No. I say here. Then it takes it. So you can't do it in the binding expression. You have to do it down here. Wow! Holy cow. Okay, let's strip out a whole bunch of C. We don't need the sequence. We don't need the labels. We don't need to do an on after render async. We just need to do that. I'm not sure why I do it that way. Wouldn't that be enough? Oh, I threw the baby out with the bathwater. It took out too much. I need start though. We don't need the sequence. We don't need labels. We do need that. We do need that. Don't 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 need that. So in all three cases, state's changed. Huh, that's a nice observation. I just realized that in all my other components, I should just do that because it always changes the state, right? Like here, you either do this, or you do this, or you do this. So there's no reason to have the state changing. That's a nice optimization. Yeah. Pat yourself in the back, Jason. Good job. And then in the MVVM one, no, because the state changes. Yeah, that's a different thing. Okay, cool. But here we do a whole bunch of different crap. Yeah. So, what do I want to do here? What I want to do is say, because this is, if I remember right, no, that's not awaitable. Wait all. Yeah. All right, so let's break this up into two buttons. Sequentially. That's the word I was. There. And so I want public void on create sequence sequentially. That goes here. Okay. And here is where I just do the normal stuff. Okay. Now for this one, I'm not going to do the parsing. I'm just going to assume that I am not an idiot and using system.diagnostics. Okay. Now we need to find the longest sequence though. Okay, so that should work, except we don't need to... What? Frick. Oh, I don't even need a start, because I don't care about a start. Right. I am going to determine what the start is. Range, private range is equal to 1, 2, okay, so we do that, we do that, we do that. Okay, now we want to set result equal to that goes here, this dot, and then this dot state. It's changed. Elapsed time is that. Okay, so we can show that there, and then we need parallel results. God damn it. Parallel results. That will go here. Find longest sequence sequentially, because that's really, we're not creating a sequence anymore. Parallel async, because we want to be async, right? That's the whole point of doing this. Okay. Except I have to stop now, because I know the big reveal, I really want to do this, but I can't. I really, really can't. Well, come on, Jason, you can do it. Okay, we're going to hijack this whole thing here. We're going to shove it down here. Okay. Then we come back here and we grab how we find it in parallel. And we do that here. Okay. Now, where is the async work? So, yeah, we don't need that anymore either. Because I'm the whole point was to say yeah, that tells you which one to finish. Was to actually like do this work in the background. Oh, no. I'm stupid. This is fine. This is fine. The reason it's fine is because what I'm trying to show is I'm a moron. See, this is when you do work at night. You just show how moronic you are. The whole point is to show, does this have the same time as the other one? Or do you actually literally get new tasks in different threads? Because it should be like the same cut, right? Can you actually find a processor count? Maybe. I mean, that's another thing too here is, do you actually get a processor count? So let's see if this actually even builds. I know I'm going a little over, but that's fine. That's fine. It's fine. It's fine. Come on, I know it's a lot of code for Razor. I know you can do it. No, you. Oh crap! I got a console. Yeah, that would not what I want. That goes away. Okay, so that does that. That does that. Yeah. Okay, and now I need to go to my nav menu here and put in another one. And what is the... Oh, we're doing a dash here. Okay, fine. We'll be consistent. There. All right, so here's the big reveal. If we make our WebAssembly host, okay, brought it up over here. Let's pull it over there. There's our tasks. Does everything still just run as expected? It does. Okay, cool. Let's go to tasks. So we should see two buttons. And we'll see the result and then the parallel one. Now, here's the theory, is that these both are going to take the same amount of time. Because in Blazor, there are no concept of threads. That's my hypothesis. We're going to find out. Because I don't even know how many processors this has. What was it going to consider to be I could consider the number of processes to be 1. I might want to report that. So, and this could take a brutally long amount of time. Yeah, because it's not optimized, I bet. Let's back that up. Let's make this something like, 1,000 to 2,000 at first. And then while we're also here, I also want to put in what actually is the processor count. There we go. Okay. We're back over here. Yeah, it's about the same. But it does say the processor count is 8. Okay, so let's now play with this a little bit. Let's make this like 10,000 to 20,000. It is interesting. It's actually able to grab the processor count. That should take a little longer. So about 2.5 seconds, run it in parallel. Not that, big of a change. Let's run it again. You see two. I mean, it's literally the same. So you are not getting the benefit of parallel work. Okay, in fact, let's make this about, let's say 50,000 to 60,000. Okay, and we'll run this one more time because I want to get it to at least long enough to see. And then that's right. That's something else I wanted to add, which is, so we got that done. Got that done. But then I want to add a create blazing the web service host. This is for gRPC. And then create sequence service razor. Call gRPC using gRPC web, because I want to have that example in there. And this would be a perfect thing to say, okay, this doesn't work here. But really, if you're going to do this kind of complicated thing, why don't you send a request over to a service and have it do it there? And then I could say even better, what you would do is make the request, send it as a message, let that work, and then sometime later on, SignalR will signal you back and say, here are the results. And then you just show that somewhere in your app. And the app can receive the message and then notify you with a toast to say, hey, calculation is complete, and then you could go navigate to that page and see all the beautiful detail that you wanted to. Did that come up? It did. Okay, so let's come back over here. And so now it should take a little bit longer. So about 3. It's a little misleading. Like if I run this again, now things are warming up. You're seeing that it's about the same. If I keep running these back and forth, we're now getting around the 2, 3, 2, 4. Somewhere in there. But there is no distinct advantage from what I showed before. Not the console app. Even with something like this. Let's go back here and make this the thing first. Even if I flip these around, it's not going to make a difference. That's my final hypothesis for the evening. I can say find in parallel and find in range. And this should come back in about 2 seconds. 3. And this should come back in about 9. Yeah. Yeah, it wouldn't matter if I ran this, a second time. It's still going to be that much slower. It's going to be, that much more work. And I bet the one that took the most time is the last one. That'd be interesting to look at. Yeah, it's virtually the same. That would be interesting to look at to see if I go to find parallel. Yeah, it doesn't tell you how long it took, which is fine. I would not have expected it to know the length of the time it took for the task to finish. That's information you don't necessarily need it to know. Okay, so let's commit this. So this is a great illustration that right now, doing threading, or not threading, doing task-based work, we're expecting things to work in parallel, will not work in Blazor. Now here is the big kick. Okay, last thing. I know I'm going to make this longer, but since we have a server-side host, what happens when we run it there? Okay. So go to our tasks, run it sequentially. it's much faster, right? That's even more faster. You can see the difference, though. I mean, if I do this and I just keep running these back and forth, we are seeing that 3 to 4 times kind of ish difference between the two, which makes sense because we're on the server, so it's running much faster because it's not interpreted. That's one thing about Blazor that's a little unknown, is that it's not, I don't think it's actually still, yeah, I've got to find that out. Is Blazor still interpreted in WebAssembly, or is it truly compiled? I do not believe, I know that this is something that Steve Sanderson showed in a previous video of his, that they were working on a way to get it so that the code in the client would run just as fast as native code, but it wasn't there yet. What they were actually doing was like interpreting the IL at runtime, so it wasn't as fast as it could be. I don't know if they're there yet. It doesn't look like they're there yet because running it in the browser is significantly slower. But this is also an interesting point to show, hey, run it on the server. That's where it actually is going to be, just by that running it on the server is going to be much, much faster. But this just shows, I mean, honestly, your client-side technology here, arguably you should not be, that should not be responsible for doing complex calculations. That data, that type of stuff, you've really got big workloads, throw them on a server somewhere. Do it in that kind of fashion. So that's cool. I got more work done. Did I commit that? I must have. Yeah, I think I did. Okay, so I'm all out of time for this. There's maybe some episodes I'm going to do tomorrow and over the weekend to continue on this. I'm having fun. This is just fun to play around with this stuff. And yeah, I still want to try to get the Selenium thing up, but we'll see. The Blazor, the gRPC stuff with gRPC Web is actually a little bit more interesting to me right now, but yeah, we'll see. Okay, cool. So I'm all done. Thank you all for watching. Leave comments and questions below. See you in the next episode.